now we're going to work through the worksheet for today, which has 5 problems. And the first couple are pretty long and the last 2 are pretty short. So for this first problem, I'm going to switch over to the iPad. This problem is called TCP in action. And here we're going to imagine that we have a sender sending 1,000 bytes of data. And we're sending using TCP. And the packets are going to be of size 100 bytes. Our window size is 300 bytes, which is enough to hold 3 of these 100-byte packets. And the ISN is 99, so D100 is going to be the first packet that we send. I'll just point this out that D100 is going to contain bytes 100. So this will have the sequence number bytes 100 through 199, but it'll be like of the actual file that we're sending of the data, it'll be bytes number 0 through 99. And this is because the very first byte in our file is going to have the sequence number ISN plus 1. ISN plus 1. So that's why byte 0 in our file is actually sequence number 100. Now this problem, we assume that TCP fast retransmit is not enabled, which is the thing that that resends packets when duplicate acts are detected. And so instead we're going to rely on timeouts to be our mechanism for sending packets. Now, let's look at our table. One other important piece I'll circle here is that the initial transmission of 200 and 700 get dropped. So let's go through this table together. One funky thing to look at is that there's no times here. There's just a number for each row. The reason that is that here the actual timing of the events doesn't matter. Rather, what's important is the sequence of events. And they're all kind of overlapping. And so if we start here, the very first thing that happens is D100 is sent. So this is bytes 0 through 99, or sequence number 100 through 199. And this packet is going to arrive, and the receiver is going to generate a cumulative ACK. Now the window size we saw was 300 bytes. So what that means is all 3 of these are going to get sent basically at the same time, because the initial window, 100, 200, 300, 100, 500, 600, 700, 100, 900, and 1000. So our window is going to cover sequence number 100 through 399, right? So be data 100, D200, D300. So all 3 of these packets get sent at the same time. And on the other end, what happens? Well, D100 makes it, and ACK200 is generated. D200 gets dropped because in the problem we say it gets dropped, and D300 makes it as well. So at this point, it's a good time to pause the video and think about what happens next. What is the next event that occurs? I'm going to go on now and walk through the answer. The next thing that happens is as soon as we receive ACK200 at the sender, this window is going to move forward. So this window is going to move forward by 1. So now the window starts from 200. We've already sent 200 and 300. And now we're able to send 400. So we've uncovered a new packet that we can send. T400 wasn't sent on a timeout. It's not dropped. But the question is, what will our receiving end do when it receives D400? Well, TCP uses cumulative ACKs, and so it's going to ACK200 itself. ACK200. Now, at this point in time, we're kind of stuck the sender receives ACK 200, right? This ACK comes back, but the window can't move forward because again, the ACK contains the sequence number of the next byte of data that the receiver is expecting. So that's why our window starts at 200. Even though we just received ACK 200, that means that the total amount of data is everything up until 200 that's been received. So at this point in time, we're stuck until the timeout happens. And whatever that timeout value is, whether it's 10 seconds or 3 seconds, once it occurs, TCP is going to resend just the packet that is being requested. So just the first packet in the window, because that is the thing that timed out. So D200 gets sent. That packet is going to arrive. And now what ACK is the receiver going to send back? Well, in TCP, we don't throw away packets that are out of order. The receiver holds on to them. And so the receiver had received 300 and 400, and now has received 200. And so now the ACK that gets sent back is A500. So now our data packet offset is D. We are at this point in time, once we receive back ACK 500, this whole window is going to move way forward. It's going to jump forward. And now 500, 600, and 700 are all within the window. And so all three are going to get sent. And this is wonderful. So D500 is going to generate ACK 600. D600 is going to generate ACK 700. But now D700, in the problem we state that D700 gets dropped. So this packet is dropped. And I should mark this here, right? This D200 in kind of row 4 here, it gets resent on a timeout. So I'll mark that in my table. Now D700 gets dropped, and so no ACK is received. No ACK is generated, and the sender receives no ACK. But when we get back ACK 500, ACK 600 here, sorry, our window is going to move forward by 1. And when we get back ACK 700, our window is going to move forward by 1 as well. So when each of these ACKs gets received, it uncovers a new packet that we can send, packet 800 and packet 900. So those are the packets that get sent, D800 and D900. But what's going to happen? When the receiver receives packet D800, it's going to ACK A700 because these are cumulative ACKs. So this ACK is going to say the next byte that I need to see as the receiver is byte 700, or specifically the byte with the sequence number 700. And same thing happens here. D900 generates an ACK that says A700 because the receiver is missing D700. And so again, we have a timeout here. We're going to wait however long after our timeout, after this D700 gets sent and dropped, and then D700 gets resent. At this point in time, 700 is now filled in, and so our whole window, well, before the window moves, sorry, D700 on the receiving end, the receiver has already received 800 and 900, so it's going to ACK 1000. The whole window is going to move forward when the receiver receives this, and packet 1000 is going to get sent. Oh, sorry, when the sender receives this, and the ACK that gets returned is ACK 1100. And this concludes this table. Now, our next question asks, if the round trip time of the link is 10 milliseconds, and the timeout is initially 3 seconds, what's the total time needed? So we can do the math here. I'm going to go back. All 3 of these packets are sent at the same time, at the very beginning, all 3 of these packets. So the time from 1 to 3 is going to be 1 full RTT. And specifically, I just want to point out, so remember, our timer starts, it gets reset every time we receive an ACK, a new ACK. And so actually, these 3 get sent at the same time, but the important thing is that this packet number 1, it takes RTT time for the sender to receive the cumulative ACK A200. And at the point that it receives a new ACK, it's it's going to reset the timer. So after RTT time, the timer gets reset. And then, D400 gets sent, and A200 is received back. That takes some amount of time, but it's not super, because the RTT is 10 milliseconds and the timeout is 3 seconds. This is happening all while the timeout clock is ticking down. And I'll actually switch to the slides here to show this visually. So 100, 200, 300 are sent. It takes 1 RTT to get back the ACK 200. At this point, the timer starts. And D400 is going to get sent, get back an ACK 200, great. This right here takes another RTT, but at the same time, within this RTT, the timer has started. And so it'll take whatever the time of the timeout is for A200 to get resent, D200, sorry. So after this timeout, we get row 5 in our table where D200 gets sent and A500 comes back, and that takes another RTT. So now by the time we get to row 6 in our table, we have 1 RTT followed by 1 timeout followed by 1 RTT. Now, again, we operate back in this normal mode. We send 500, 600, 700. It takes 1 RTT to get back ACKs 600 and 700. And 700 is going to be the last new ACK that we receive. So 800, 900 are going to go out, but we still receive ACK 700. And after receiving ACK 700, the first ACK 700, this 3 seconds of time passes, TO. And at that point, we retransmit and we receive back an ACK for A1000. And finally, we send D1000 and receive back an ACK. So our total time ends up being 5 RTTs and 2 timeouts, which is 6.05 seconds.